Do you know what it takes to take the best wheat from the field to your table in that delicious, crusty loaf of bread? Well, more than you think. We get the inside scoop on a big wheat breeding operation here in Cambridge. We chat with a plant scientist who uses her science savvy and green thumb to find the seeds that perform better to supply farmers with the best crop.
You're listening to The Science Show on Cambridge 105.
In this section called Scientists at Work, we talk to people who, for some reason or another, find themselves working, researching or thinking about science in Cambridge, England. Breeding plants commercially. That's the job of local company KWS, who are based a few miles south of Cambridge in the lovely village of Thriplow.
We talk with a plant breeder who specializes in making better versions of wheat, maize, oilseed rape, and sugar beet. The scientist is Gillian Covey, technical operations manager and plant breeder specializing in spring wheat.
And Chris and I had a fun hike through the wheat fields to find Gillian on location. Let's have a listen now.
We're here today at Thriplow. Also along is Roger Frost. So we're just outside Cambridge, and what do you actually do at this location?
So here in Cambridge, we breed several different types of crop. We also sell them commercially as well. So we work in oilseed rape, sugar beet, maize, wheat, barley. We're basically working the different crops and breeding them here and also selling them commercially as well.
So what is the objective of the wheat department, so to speak?
So we are developing new varieties for growers that should have increased yield, better disease resistance, and that might be better disease resistance to existing diseases or new diseases or possibly new races of a certain disease that come in.
Okay.
But also they can have a different end use or improved end use, such as the bread making quality, biscuit making quality for whiskey, beer in the case of barley. A lot of different end uses there. The oilseed rape, perhaps with the oils. So it's end use, yield, disease resistance, pest resistance when we can bring that in. We use all these things and try and develop a competitive variety in the end.
Okay. We've been growing wheat for years, so how come we haven't sorted it out yet?
That's a very good point, very good point. We've basically more than doubled the wheat yield in the last 50 years. And a lot of that has been through the breeding, and also the wheat yields have also increased due to other factors such as semi-dwarf varieties have come into the wheats and the chemical side as well, because of course 50 years ago there wasn't as much chemical application, and there are new chemicals such as the strobilurins when came in, the SDHIs that you can use on the plant. They also have a stay green effect and they also increase the yield as well.
So what is this SDHI, sorry?
It's a chemical that can be used on the plant to protect against disease and also has a stay green effect, and it would be used for increasing yield.
Take us inside what you actually do.
We might have a wheat variety that we've currently got on the market that succumbs to a certain disease, and so we might have another variety that doesn't quite yield as much as this variety, but it has resistance to this disease. So really we want to combine the two. Through traditional breeding can take quite some time, but we will take one variety and that will be the mother variety, and then we'll take the other variety and that will be the father. With the mother variety, we need to remove all the male parts so it becomes just female, and then we'll use the pollen from the father variety and actually pollinate this one variety to create a cross. And that one cross, we will do about 2,000 of those crosses in a year on just one of the wheat programs. And then from that starting point of the cross, we'll multiply up the seed. So for each cross, we might create about 5,000 individuals. And then from those 5,000 individuals, we'll slowly start to pick which ones to keep. Eventually, 10 years down the line, we might end up with one left in the cross, perhaps, which is the one that hopefully might make it onto the market. So it's through a gradual process of constant selection every year and the self-pollinations of the crops. These are inbred crops that we will select a future variety that would have the improved characteristics.
So that's very interesting. So how do you actually go about figuring out which particular plants of wheat you want to propagate? How do you go through the selection process?
Each year we might have 2 million potential varieties in the wheat programme. And it's all about selecting the right ones of those to take forward to the following year. And then obviously we take those forward to the following year, And we also have that 2 million from the previous year and the previous year before that. So each year it sort of builds up on top of each other. So out of the 2 million or so to start with, we will walk through and look at all those plants, and we will choose by the way that the plants have tilled, so the amount of stems and ears that they have on them in the case of wheat, their height, whether they're stiff enough in the stem, whether they're quite disease resistant already, and whether the ear is a nice type as well. So we'll have a look at all those different characters, and if we'd like to take it forward, we'll take one ear from the wheat, and then that one ear will go on and progress to the next year.
Very neat. So you mentioned before about different types of wheat being better for things like bread versus making whiskey or something. So how do you decide what types are great for what?
Within all the varieties that are available in the UK at the moment, there's a list, a recommended list of some of these varieties, and they're in different sections. So we have a bread making section, biscuit making section, a feed wheat section that goes towards the animal feed. So generally, you need to cross together the wheats from those sections to get the appropriate wheat that you want. So say we want to create a bread-making wheat, we would cross either two bread-making wheats together, but we could do a bread-making wheat with a feed wheat. Then we need to do extensive testing through the years to make sure that it actually meets with the requirements for bread making. What we generally do is, when we start off with the 2 million, it's very difficult to test on that many plants. So we have to wait until we've cut them down. And so slowly over the years, we'll do more tests, small tests to start off with in the lab, such as just a little test on the protein. So this might be protein quality or protein quantity. And then we'll increase these tests. We'll test the enzyme activity as well. That is a huge influencer on bread quality. It can basically influence whether you end up with a sticky loaf or a nice looking loaf. And then later on, once we've probably cut things down to just a few hundred, we'll think about talking to millers and getting millers to test the varieties as well. And they will bake us a little loaf, like the loaves you get in the shop. They bring them in and they cut them open and they prod them and look at the colour and things, and generally tell us whether they think that they're suitable for going forward to making bread making quality. Now to us, quite often with our eyes looking at the loaf of bread, you'd be happy with any of them in a sandwich really. So it's quite an art to the miller's subjective view.
That's awesome. Now how many varieties of wheat are there?
On the market, there's probably about 25 at the moment that are still growing around. They're constantly changing. You'll still find a few farmers that will grow some of the older varieties, and then sometimes you can still be surprised about just how old some of the varieties are that some of the farmers are growing. And then a lot will just swap constantly onto the new varieties and try and get the highest yields.
So in an ideal world, do you think it would be better if we had more varieties to choose from or focused on a fewer that were really high performing?
I think it gets quite complicated if you start getting too many. And that's where you can end up with the farmers actually knowing which choice to make. And so we wouldn't want any more, I think. It would probably better to have a few less. But then we need to make sure we have the right ones. And then also with the different climates and situations across the whole of the UK, we do need quite a few different strains, different types, really, to suit those areas.
That's a really good point. So different types of varieties have different abilities to respond to local environmental conditions and pests and things. So in terms of genetic variability, having more variability in wheat genotypes would mean that there's more opportunity for them to exist under different challenging conditions. So how do you guys manage that issue of maintaining genetic variability when you do things like, I think it's called single seed descent?
Yes.
It's one of your methods for trying to rapidly breed a particular type of wheat that has characteristics that you like and you want to propagate. So maybe you could explain for us this single seed descent and what it means in terms of genetic variability.
The process that I described before of 2 million varieties down to just a few at the end is the traditional breeding method, and that's for inbred varieties that you progressively select over the years to take out all the segregation.
And what does inbreeding mean?
Inbreeding is where it self-pollinates And so you end up with a variety that's an inbred crop. So we use a couple of methods, one of which you just mentioned, single seed descent, and that can reduce the amount of time that it takes us to get a variety to market. The other method that we also use is doubled haploids. Doubled haploids is somewhere where it's even quicker than single seed descent, but it's quite labour intensive and quite expensive. But it's a method where we can be even quicker to market. But interestingly, how you've said that genetic diversity is important, with double haploid technology there is less points of recombination. So that would be a problem where you may have to bring in some extra genetic diversity over the years. Single seed descent is pretty much doing 2 or more generations in a year within a greenhouse, and we literally grow up a wheat plant to just produce 1 ear. We take 1 seed, so a single seed, sow that back where we grew the original wheat ear, and then again produce that. And then if we wanted to do another generation, it would be another single seed, sown again, grown up to 1 ear. And we can force that through the greenhouse quickly, perhaps getting 2 generations or even 3 generations in a year. There are other methods. You could also use the southern hemisphere. So we don't currently use this as a company ourselves, but other companies do, and we have done in the past, is to go to New Zealand, for example, or South America, and you can do a generation there and a generation here in a year, very similar to using the greenhouse.
Okay, so the benefit of going to the southern hemisphere is...
That's just to get another generation in a year, the same as...
And the double haploid, how's that?
The problem with breeding a new inbred variety is it keeps segregating over the years. We've done a cross, and then it keeps pollinating itself, but until the genetics level out, and we've got the homozygous variety, it takes a few years to do that.
And homozygous variety means?
Uniform genetics. Yeah.
So the alleles are the same?
Yeah.
On a chromosome. Okay.
Yeah.
Cool.
Yeah. So with doubled haploid technology, we make the cross, as we did before, so parent 1 with slightly poor disease resistance, and parent 2 with better disease resistance but not quite as much yield. They go together, so we made the cross, and instead of going the normal traditional breeding route, we sow those seeds of the cross, and then we use some maize pollen to pollinate the plants, instead of allowing it to self-pollinate. So instead of allowing those plants to self-pollinate, you pollinate it with the maize, and the wheat is tricked. It actually thinks that it is pollinated, and it starts to form embryos. But at some point in that process, it realises that it's not going to work, and it kicks out the maize chromosomes. And so we end up being able to rescue embryos in the lab, known as embryo rescue. This is down microscopes. We basically break open the caryopses, so these fluid-filled sacs where the seed is, and remove the embryos. And then we look after these embryos on Petri dishes, feeding them with a nutrient media, and we grow them up and produce green plants. Now, the problem with these plants is that because we pollinated with the maize pollen and then they kicked out the maize chromosomes, we've ended up with only half the number of chromosomes per plant. So that is your haploid. So haploid plants. So we need to double the chromosomes to be able to bring them back into being proper plants. So we use a chemical called colchicine, which is well known within the plant breeding industry. And we apply colchicine and then double up the plants to produce doubled haploids.
So that takes you back to diploids.
That's right, yeah.
Right.
And then, so we can then produce these plants either in the greenhouse or in the field, and then grow them up. And the genetics then are now fixed and uniform. And so we no longer have to try and breed out the rest of the segregation because it's then fixed. So you fixed it within a year. So all you need to do then is see whether they're good enough in terms of yield, disease, quality, and then you can multiply them up and they're ready for the market.
Thanks, Gillian. That's really exciting to hear how that process works, right from the field right to the market. That's quite neat. So where do you see the future of plant breeding going?
Quite often we'll get quite excited about some of the crosses when they come through, and you can see there's huge potential. When we see that within some varieties, we can try and accelerate them and get them to the process of official trialling as soon as possible. And there's an official trialling process that all varieties need to go through. From when we initially purify a variety that we have as a stock, we need to enter it into the national list testing system. There are 2 years of national testing. This is for wheat. And then there's another year of the recommended list testing. And we need to, during this phase, we multiply up the varieties, constantly check the purity of the varieties, but they also get tested all over the UK. So including Ireland and Scotland, Wales, and in several different regions within the UK. If they manage to get through all of these phases, and then also they get recommended at the end, then that's when it becomes a variety. And by that stage, we should have been able to assess the potential of the variety and have produced multiplication fields of enough size to be able to then sell the seed out and produce more seed, and also produce seed for actually going out to the intended end uses.
Can you work ahead of that testing process?
We can. We need to be very sure about a variety because it's very expensive for us to put out several hectares of a variety. We need, at the early stages of a variety, you need to keep it very pure as well, so we need to have teams walking into those crops, taking out any off-types. And so it can be quite expensive. So if we enter, say, 10 to 15 varieties, we wouldn't be able to do that for all of those varieties. So we'd need to pick out which ones and then make sure we get the right ones to probably accelerate even further and put the money into.
Thank you so much for chatting with us today, Gillian, and we'll put up a link to KWS on our podcast page.
Thanks very much to Gillian Covey of KWS in Thriplow. That's pretty much all for today's show. Scientists at Work is made by the Science Show team on Community Radio Cambridge 105. You can also find past episodes on the website www.cambridge105.fm. You can also subscribe to future podcasts with the iTunes Store. You can get in touch with us on the email science@cambridge105.fm or on Twitter @105science. Till next time, it's bye from the Science Show team of Roger Frost and Chris Creese.
You're listening to The Science Show on Cambridge 105.